Okay, one condition, this quadratic has no real roots, so condition for no real roots is that the discriminant is less than naught. So there's no real roots if b squared minus 4ac is less than naught. Okay, identify a, b and c from the quadratic. So a is the coefficient of x squared, b is the coefficient of x, which is 8, and c is what's left over, which is k. So substitute into that. B is 8, so that's 8 squared minus 4 times a, which is 3k minus 2, times c, which is k, and I want that to be less than naught. So 8 squared, 64. Expand this bracket, bring the k, do the 4 times k first of all, so that's minus 4k bracket 3k minus 2 less than naught. 64. And expand the bracket, minus 4k times 3k is minus 12k squared, and minus 4k times minus 2 is plus 8k. I want that to be less than naught. So rearrange it in the order we see a quadratic. So it's minus 12k squared plus 8k plus 64 is less than naught. And then 4 is a factor of those three numbers, so I'll divide by 4. So it's minus 3k squared, add 2k, add 16 is less than naught. Now then, I want to change this in the question, it's 3k squared, I got minus 3k squared, so I'm going to change the signs throughout, so I'm going to in effect divide by minus 1. And when you times or divide by a negative value, the inequality changes the other way around. So that's going to be 3k squared minus 2k minus 16, and now that has to change the opposite way to a greater than 0, and there's the condition shown in the question. Now then, it says find the range of values of k satisfying this inequality. Now if you don't get what they got in the question, you can use their answer and go on and solve that inequality. And then to solve that inequality, we're going to factorize this expression to get the key values. So it's got to be 3k and k, and times up to make 16. 8 2's, so if I got 8 there, 2 there, so I got minus 8 times k, add 6k, that gives me minus 2. That's one way to factorize it. Another method to factorize 3k squared minus 2k minus 16, I can also factorize it like this, 3k in each bracket, all over 3, and I multiply 3 times 16 is 48, and then I look for two numbers to multiply to make 48, subtract to give 2, so that would be 8 times 6, and to get minus 2 would be minus 8 plus 6. And you factorize what you can in the bracket. The first bracket doesn't have a factor, second bracket 3 is a common factor, so that's k plus 2 over 3, they cancel out, and as you can see I got the same factorising there. So there's an alternative way of factorising. So the key numbers, because I'm going to sketch this now, the key numbers are k being 8 over 3 and k equaling minus 2. Okay, they're not solutions of the inequality, they are the key numbers I need, so that when I sketch the graph I got where it crosses the axes. So I'm talking about minus 2 and 8 over 3. So positive k squared, so this shape, when I draw it, will look like that. And this line here is where this expression is equal to naught. I want to know where it's greater than naught. So it's greater than naught when this graph is above this 0 line here. Okay, so I want values to the right of 8/3 and to the left of -2 for the graph to be above the axis. So k belongs to, here's my solution, I'm going from minus infinity up to -2, or, so I join that for the union, from 8/3 up to infinity. Now the shape of the brackets, infinities will always have a round bracket on. I look at the inequality sign as a strictly greater than, so it's going to be a round bracket because I can't equal these values. And there's the solution.